And I guess by now you all know that I'm actually a petrol head, but nevertheless, technology is very interesting, and the use of electric vehicles is to some extent unavoidable. And it's not that I'm a fan of EVs, but I do like technology. So if you're planning to buy a second-hand electrical vehicle, the most critical component is the battery. So in this video, I'm going to try to give you some advice on what to look for when you buy a second-hand electric vehicle. In the first part, we're going to look at two main parameters, the state of health of the battery and the state of charge. And those are two parameters that will determine how good the battery still is on that second-hand car. And in the second part, we're going to dig in a little bit deeper on the technical side of state of health and state of charge. If you're buying a standard combustion engine car, we look at the age and we look at the mileage. And then we might do a compression test, we might do a blow-by test on the engine, but we get a pretty good indication on how well the car still is and how well the engine still is. And it's not very complicated, and you can do this with very cheap tools. Now, buying an EV is a little bit more than just looking on the age of the car and the mileage. There are different parameters that will affect the life or the health of the battery. And these are, to begin with, what was the driving style of the previous owner? Did he accelerate a lot? Was he a sporty driver? Because if you do so, you draw a lot of power from the battery. That creates a lot of heat, and we all know that heat is going to reduce the life cycle of the battery. So the driving style is a critical element in how good the battery still is. And of course, the salesman won't tell you how the previous owner drove. The second element is how many cycles has the battery gone through for recharging? And what was the method of recharging? Boost charging or supercharging takes a little bit of time, but it's not all that good for the battery. It's going to reduce the lifetime of the battery faster than a normal life cycle. The other element that comes in is, did the previous owner drive the car from 100% load on the battery to zero almost, and then charged it again to 100% or full, and then drove it again almost to empty? If this was the behavior of charging, not a good thing, because then the battery will have deteriorated much faster. So it is better to charge it up to around 70–80% and let it drain to about 30% and then charge it again. And then finally, it is important to know, how was the car stored? How was it parked? Was it parked with a 100% loaded battery for a long time? Not a good thing. Was it parked with an empty battery for a long time? It's not a good thing. Now, I'm not inventing things here. You can check it out with your iPhone or your other smartphone you have. And when you have this iPhone or this smartphone, when it's new, the battery lasts you a couple of days, but over time it's going to get worse. And as a last point, I would say every battery is limited to X amount of load cycles. So you really need to watch out for these conditions on how the car was treated by the previous owner. The problem that we're having here is that the salesman is not going to tell you, not that he doesn't want to, well, maybe he doesn't want to, but most of the time he won't know. So what can you do now to figure out how good this battery still is and how far it's still going to get you with a single charge? Now, you can get a lot of information from the battery management system that is in these vehicles, and you can look on the electronic dashboard and find out how many times it has been charged, I mean how far the action radius still is when the battery is fully charged, but don't trust that information for the full 100%. It is not really 100% accurate. Therefore, I would urge everybody who's going to buy a second-hand electrical car to have a formal report on state of health and state of charge of the battery. There are companies that will verify the battery, they will measure it out and give you those reports. And if you're serious about buying an electrical second-hand vehicle and you don't want to be fooled, you don't want to be tricked, then ask for such reports. Because after all, these cars are very expensive and you don't want to waste your money on it. So let's talk about state of health. So if you're now getting this report from this independent company that did this measurement on the battery, it will give you a figure, and it's going to be called state of health. And that is a percentage on how much amps hours the battery still has compared to its new state. So if I had a battery which could deliver 100 amps per hour, we would talk about a 100 amps hour battery when new, and the battery right now was measured and it only had like 70 amps hour, then if we work that out in percentages, then we have 70% of state of health. So in other words, your battery is left with 70% of its initial capacity in amps hour. I would even say anything below 70 is no good. Don't even buy the car. It should be better than 70. Unless you want to fit in a new battery, of course, but that's going to be expensive. But what does that do to your action radius? How far can you now still drive with this car? So let's assume, to make things simple, that your normal new driving distance, as they give you when you buy the car, would be 200 kilometers or 200 miles. It doesn't really matter, but let's say 200. With a state of health of 100%, you can drive 200 kilometers. But when the state of health of the battery is now reduced to 70%, you can't drive 200 kilometers anymore. It's going to be 200 multiplied by the state of health. So that means your maximum reachability of distance is going to be 200 multiplied by 70%. That's 140 kilometers or miles. So you have lost 60 miles of the maximum distance you can drive. That's not a good thing. And these are the easy ways you could calculate this. But that's not it. I also need to mention to you that there's the second parameter we talk about, which is the state of charge. When the battery was new, was let's say 100%, to make it simple. Then you know that you could really drive with this car the 200 kilometers and having still the same charge response from the battery during that time. But now that the battery has getting older, it's been deteriorated, we know we only have 70% of state of health, and our state of charge will have come down as well. And maybe now this is at 50%, and I'm really exaggerating now, but let's say 50%. So now really, the real distance you can drive, the remaining distance you can drive with this condition, with a state of health of 70% and a state of charge of 50%, is the 200 kilometers or miles multiplied by 70%. That gives us 140 kilometers or miles. And then you multiply this with actually the state of charge, which is 50%. So now the 140 multiplied by 50% is now 70 kilometers or miles you can drive. So with those two parameters, you can figure out how far you can still drive the car with a full charge. So to summarize, if you're going to buy a second-hand electrical car, request a formal report on state of health and state of charge. Look at these figures and then use the original stated mileage that you can take with this car for a full charge, multiply that by the state of health percentage, that then gives you the new maximum distance you can drive with the car, and then multiply that with the percentage of the state of charge, and then you have the actual distance that you will be able to drive with this car. Is this 100% accurate? No, it's not, but it's a very, very good indication. And it's about the only indication that you can get as a customer when you're buying a second-hand vehicle. If the salesman is not willing to give you such a report, then don't trust anything you see. And of course, you also want to consider the age of the car and how many cycles the battery has been loaded. Let us dig in a little bit more now to the state of health of a battery And we can break it up in basically two main areas. We have the state of health for capacity, and we have the state of health for impedance. So let's focus first on the state of health for capacity. If I was to draw a graph, and on the vertical axle, I would put my amps hour. So how many amps per hour can I drain from the battery? And on the horizontal axle, I would mark my cycles. Now let's say I start with 100 cycles here, and I'm going to about 600. It doesn't really matter now how many cycles. We know that the capacity of a battery at birth is, for instance, 100 amps. But while we're cycling the battery over time, we are going to lose capacity on that battery. And I'm talking like a lithium-ion battery now. So you would see a degradation of that. And now I'm exaggerating a little bit. But depending on how many cycles we've had, we'll have less capacity on the battery. Maybe this is now 97%. And while we have more cycles, charging and discharging of the battery, we may get as low as 70%. So that is a very important factor to consider when we talk about state of health, and that's the main part that we typically look at. However, there is another component which is very important, which is the state of health impedance. Now, impedance is a fancy word for resistor or resistance. If I was to draw a cell of a battery, I could actually draw a resistor and then the source itself. That's how we would represent it. And this is what we call the equivalent serial resistor. And that has a certain value. So when the battery is new, that resistor value is low. It's milliohms. So milliohms, very low. So when the battery is new, I could say that the impedance is very low. So if I now would use the same graph, but now I would call the vertical axle impedance, then that would be in ohms. And if the battery is new, I would have a very low impedance, some milliohms. But while we go through the cycles, that value of the ESR is increasing, so we're getting more resistance. So that would be a curve that would go up. So the more cycles we do, the higher the impedance becomes. Now, a higher impedance is becoming a bit of an issue, because if we're going to floor our car, we're going to demand a lot of power, we're going to drain a lot of amps from the battery, that current needs to flow through the ESR. And the bigger the impedance of the ESR, the bigger the resistance, the more voltage drop we get, but the higher the temperature becomes. And we all know one of the main enemies of a battery is a high temperature. And if you're talking about lithium-ion batteries, it is not uncommon that they can catch fire if they get too hot. So therefore, it is very important that the battery management system is checking and controlling the temperature of the battery cells. And therefore, they will put something which is called a thermal limit. So at a certain point, the battery is going to get hot, especially if you demand a lot of power from it. And when that point is reached, the temperature is at that point, the battery management system will actually reduce the power that you can get, or the current you can get out of the battery, to get this temperature down to an acceptable level. So, but what does that actually mean? Well, when the battery is new, we have a low impedance. So there will be a spec on the battery saying, look, you can go full power on the battery for about 10 minutes. This would be about what you would have. And I'm just giving an example now. But while you have more cycles, the ESR value maybe doubles up. And if it doubles up, let's say around here, we're going to reduce this time to 5 minutes before we get to the critical temperature. And then the thermal protection will kick in. So over time, we have now two effects on the battery for the state of health. We have a decline of the capacity, but we also have a decline in the time, the performance time. So the time that you go into demand maximum current from the battery pack is going to be reduced over time just because of the thermal limit. In a nutshell, the state of health of a battery is the state of health on capacity. So how much capacity does the battery have over time after so many cycles? And the state of health in impedance, which is going to affect tremendously your performance. When I say performance, in a new battery can allow you for 10 minutes at full power drain, while the battery is getting older and have more cycles on it, it's going to reduce that time maybe to 5 minutes, 6 minutes, 7 minutes, whatever it is, depending on how many cycles you had and a bit depending on the type of the battery and how the power was consumed. If you're into racing with electric vehicles, then the state of health for impedance becomes very important because that will determine how long you can go on full power in terms of time by draining the maximum power from the battery before the thermal limit will kick in. The next thing we want to talk about is state of charge of the battery, and we can break it up in two main components. State of charge in terms of capacity and state of charge in terms of energy. So the state of charge in terms of capacity is nothing more than the remaining amps hour in the battery over the total capacity of the battery. So if the battery had 100 amps hour and the remaining capacity is 50 amps hour, we talk about a 50% SOC because we have already consumed 50%. If I was to draw a graph with the vertical axis being the volts per lithium icon cell, then a fully charged cell is 4.2 volts and a depleted one is 2.5 volts. And on the horizontal axis, I would have my amps hour and I have it back to 100. So 50 amps hour would be somewhere in the middle here. We can then, in essence, say that if we were to look on how the power is consumed on the car, that we have a curve something like this. And here, of course, our battery is dead, and here the battery is fully charged. And over time, while we are consuming power or amps, the curve will move more or less this way. Of course, this is not 100% accurate, this curve, but this is how it's going to go. So we could say that in this case, when we have consumed 50% of the capacity, that we are sitting around this point here, right? This is where we are. However, when we look at this block here, look at this, how big that is compared to that block. This whole area, this is what we call the energy, because energy is the most important part. How much energy does the car has? You know, we've got our voltages and we've got our amps, but what is the total energy? And the striped area here is an energy area. This one is less. You can see that this whole surface is smaller than this one. So if we were to define the SOC energy level for fuel metering, then we probably would have to move this line here, maybe around here somewhere, so that this area now is about the same energy level as this area. So it could very well be that here we are at 42. So now this area here is about the same as that area in terms of energy. So the SOC capacity is 50%, but the SOC energy is only 42. So you can see that SOC energy is not the same as SOC capacity. Now, for most cars and battery management systems, they're going to go with the SOC energy setting. We have come to the end of this video, and I hope that you enjoyed it. There are, of course, many, many more aspects to batteries or battery packs in electrical vehicles.
for which we could talk for hours, but I just scratched the surface, the most important parts, so that when you're going out to buy an electrical vehicle on the second-hand market, you can do some of your own basic calculations based on that SOH report that you get. And maybe you have also the SOC values, which might help you in assessing how good or how bad the battery is, and if the price for the EV is not over the top. Thank you for watching, and I'm looking forward to your comments. Thank you.